Now, the fourth law. Pay adequate attention. The fourth law is the fractional indices. If we have something like this, a raised to power x divided by what? Y. A raised to power what? X divided by what? Y. This is the root. At the index here, you have the denominator and the numerator. The denominator here represents the root. Here represents the power. This is the same thing or equal to y root of a raised to power x. Y root of what? A raised to power x. I want you to pay attention. If you understand these laws very well, it will help you when we shall be solving multiple questions. The laws are very simple laws. So I want you to get the rudiments. Getting the rudiments will help you understand the topic very, very well. Let us take an example here. If we have something like this, eight here raised to power 2 over 3. 8 raised to power what? 2 over 3. There is an alternative way to solving this, but let us solve it with this formula first. We have 8 raised to power 2 over 3. This is equal to cube root of 8 raised to power 2. Cube root of what? 8 raised to power 2. I want you to pay attention. It is different from 3 root 8. Cube root of 8 is different from 3 root 8. You will understand this better when we shall treat sword. But this is what I mean and not this. Alright. Now, the cube root of 8 raised to power 2. Then we'll ask a question here. What is the cube root of 8? The number will multiply by itself 3 times to give you a result. So here we talk about the cube root of 8. So what do we multiply 3 times to give us what? 8. The number we multiply 3 times to give us 8 is 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 2 is what? 8. So, the cube root of 8 is 2. This will be equal to the cube root of 8 here. What we have here inside the bracket is what? 2. But there is an exponent here. There is a power here. There is an index here. So this exponent, this power, or this index here, which is what? 2. We put it here. Therefore, our result here should be 2 raised to power 2. And 2 raised to power 2 simply means it's equal to 2 times 2. 2 times 2 is what? 2 times 2 is what? 4. Which is our final answer. But if you are asked to solve, you stop here. Otherwise, if you are asked to leave your answer in index form, you stop here. 2 raised to power what? 2. But when you are asked to simplify, you stop here. Or simplify and leave your answer in index form, you stop here. I hope you are getting me. There is something I am going to introduce you to. that will help you. I want you to have this at heart. If you do, it will help you to solve a number of questions or problems in indices. So, I want you to look at the board. Take down the examples here. Please look at the board and take down the examples. You can pause it on your DVD, on your laptop, and look at the board. Take down the notes. After taking it, then we move to the fifth law. But before the fifth law, I will introduce you to a table that will help us to solving questions and problems on indices. Now, we have taken the first law, the second law, the third law, and the fourth law. We shall look at the fifth law. Remember, these laws could be treated in different order depending on the person teaching it. So let us look at the fifth law. Before then, I told you that I will introduce you to something that will help us understand this topic very well. If you look here, you will see that I have written down some of the index or indices that will help us understand this topic very well. This is what we call the index notations. 2 raised to power 1 is equal to 2. 2 raised to power 2 means how many times have we multiplied 2? Here, we multiplied 2 times here. 2 times 2, 4. 2 times 3, that is 2 raised to power 3 means 2 times 2 times 2, which is 8. 2 raised to power 4 means 2 times 2 times 2 times 2, which is 16. 2 raised to power 5, that is multiplying 2 into 5 times. We have done that at the beginning of this class, which is 32. 2 raised to power 6 is 64. You can use your punch there. But if you know these things and learn them by heart, it will help you. 2 raised to power 7 is 128. 2 raised to power 8 is 256. 3 raised to power 1 is 3. 3 raised to power 2 is 9. 3 raised to power 3 is 27. 3 raised to power 4 is 81. 3 raised to power 5 is 243. 4 raised to power 1 is 4. In that order until you get to 9 raised to power 3, which is 729. So, I want you to memorize this, know it, learn it by heart, and it will help you in solving problems that have to do with indices. Now, let us look at the fifth law. Remember, at the beginning of this class, I said, if we are using alphabet, I told you that if A, X, and Y are real numbers, at a time we shall also add A, X, Y, B, as the case may be. But I want you to pay adequate attention so that you understand this topic very, very well. Now let's take the fifth law. A raised to power X bracket Y. This simply means this is equal to A raised to power X times Y. Some notation will say X dot what? Y. But this is X times what? Y. Which is equal to A raised to power XY, as the case may be. This is A raised to power what? XY. Or A raised to power X times Y. Let us take an example. If we have something like this, 3 raised to power 5, like we have used in our first, second examples. Three raised to power 5 in bracket 2. The 5 and the 2 here are exponents. They are what? Exponents of 3. This is equal to 3 raised to the power 5 times 2, which is equal to 3 raised to the power 10. This is just the 5th law. I want you to pay attention. Indices is a very simple topic, but you will get to a stage where you have some complex questions. And if you pay attention very well, you will understand what the rule of the game is all about. Let us look at the 6th law. The 6th law is what we call the negative indices. The what? Negative indices. It is written this way. A raised to power minus x. A raised to power what? Minus x. Now, this is equal to 1 over a raised to power x. 1 over a raised to power what? X. I want you to understand this. It is different from a raised to power 1 over what? X. Please, it is not the same. So, this is the 6th law. I repeat again, this is the 6th law we shall be what? Considering. Now, let us take an example. If we have something like this, 3 raised to power minus 2, this will be equal to, remember, I said if a and x are real numbers, we have represented a with 3, we have represented x with 2, and this is the negative what? Sign, which is the reason we called it a negative indices. Now, this will be equal to 1 over 3 raised to power 2. 1 over what? 3 raised to power 2. Look here. This is A. A here representing 3. A here 3. 2. X here 2. So this is the inverse here. So this is 1 over 3 raised to power 2, which will be equal to 3 raised to power 2. Now look here. What is 3 raised to power 2? This is 3. 3 raised to power 2 is what? 9. Therefore, this will be 1 over 3 raised to power what? That is 1 over 9. Because 3 raised to power 2 is what? 9. This is our what? Answer. If you are asked to simplify, but if you are asked to leave your answer in index form, this is where you will stop. Am I communicating? All right. Now, this is the 6th law. Then we shall look at the 7th law. I don't know if the space here will permit us. All right. Pause and copy whatever we have at the board there so that we can continue. We have treated 1, 2, 3, 4, 5, 6. We shall look at 1 or 2 more laws. If we do that, then we'll solve multiple questions in indices. Now, let us take the 7th law. The 7th law states that a raised to power b all over what? X. X here is the exponent. X here is the power. X here is the index. I hope you are following. I want you to understand this topic very, very well. Now, the exponent here, or the index, or the power, affects A. It also affects what? B. Therefore, this is equal to A raised to power X all over what? B raised to power X. Let us also use an example to expatiate on what we have what? Done. So the example will be what? 3 raised to power what? 4, all raised to power 2. 3 raised to power what? 4, all raised to power 2. I want you to understand this topic very well. So look at the board. This is equal to, the A here is 3, X here is 2, B here is what? 4. So this will be equal to 3 raised to power 2 all over 4 raised to power 2, which is equal to 3 raised to power 2 is what? 9. If you watch here, 3 raised to power 2 means 3 times 3, which is equal to 9. All over 4 raised to power 2. 4 raised to power 2 here means 4 times 4, which is 16. So 4 raised to power 2 here is 16. So the answer here is what? 9 over 16. That is the 7th law. When we shall be solving multiple questions, you will understand better what these rules or what these laws are talking about. Let us take one more law, which is the 8th law, the transformational law. Just like the negative indices, but this is the transformational law. Like I said, just like the negative indices, but this is the transformational law. So pay adequate attention as we take this law, and that is our last law for today. Now, the law states A over B raised to power minus X over Y. A over what? B raised to power minus X over Y. Do you know why it is called the transformational law? I will give you a shortcut on how to understand this law perfectly well. This is equal to, this is a negative sign. And for us to do away with this negative sign, the index will remain, but we shall transform this fraction here. The denominator will come up while the numerator will come down. We shall make an inverse here to do away with this negative sign. Am I communicating? So look at it. This will be B over A all over X over Y. That is why we call it the transformational law. I said that is why we call it the what? The transformational law. So we have taken the first law, we have taken the second law, we have taken the fourth law, we have taken the fifth, the sixth, the seventh, and now the 8th what? Law. We shall take an example to enable us understand this law. So let's take an example. 8 over 27 all over minus, are you following? 2 over 3. 8 over 27 all 8 over 27 raised to power, 8 over 27 raised to power minus 2 over 3. To solve this problem or question, let us first of all do away with this negative sign here. We shall apply the transformational law here to do away with it. So this will be 27 over 8 raised to power 2 over 3. 27 over 8 raised to power 2 over 3. By transforming this fraction here, making this 8 over 27 to become 27 over 8, the negative sign here disappears. Then we have the index, the exponent, or the power 2 over 3 here, which is equal to 27 raised to power 2 over 3 all over 8 raised to power 2 over what? 3. Am I communicating? I want you to follow effectively. You will understand what the rule of the game is all about here. Now, 27 here is the same thing as 3 raised to power 3. So, 27 here, this will be equal to 27 is the same thing as 3 raised to power 3. Multiply by the index there, 2 over 3. All over 8 here. What is 8? 8 is the same thing as 2 raised to power 3. 8 is the same thing as what? 2 raised to power 3. Multiply by 2 raised to power 3. With this, we can solve the question with ease. 3 will cancel out 3. 3 will cancel out 3. This will be equal to 3 raised to power 2 all over 2 raised to power 2, which will be equal to 3 raised to power 2. 3 raised to power 2 here is 9. And 2 raised to power 2. 2 raised to power 2 here is 4, which is equal to 9 over 4. Which is equal to 4 into 9 is 2. Remainder 1, which is 2 whole number 1 over 4 as your answer when you are asked to simplify. When you are asked to do what? Simplify. Otherwise, here you have your answer in index form. So these are the laws we shall be considering for today, and we shall also look at multiple questions. We shall solve a number of questions which we shall apply the laws simultaneously to enable us solve problems on indices. So I will write down a number of questions. We shall treat them, solve them, and we end the class for today. Thank you as you follow up.